We want to use this formula shown on the right to solve this limit problem. Now, I showed in my other videos how to use substitution. Some students suggested that it's actually a very easy video because I should use the formula. Now, I agree with you. The only thing is some professors, most of the time professors will not let you use this shortcut formula. So you have to be aware of your basic methods of being able to solve these limits. All right? I'm perfectly aware that this formula exists, so obviously in this video I'm going to show you how to do it. It's a shortcut, but again, don't rely on the fact that you will be able to use this formula on your test. Most of the time you will have to find a way to solve this without using this shortcut. But let's understand how to solve this using the shortcut formula. First, let's check the given conditions. So the limit of the f of x, the first function, as x approaches the value a, should be equal to 1. Right? So that means our first function, notice that in your formula here, you will be raising, this will be basically the limit that you should match against the limit that we have. So that means f of x should be basically ln x to the 6 plus 1. So that means let f of x equal to ln x to the 6 plus 1. Then, notice that we can substitute the a value for 1. Let's just make sure that we satisfy the given conditions. The limit as x approaches 1 for this f of x function is going to be what? Just substituting the 1, right? So it's going to be ln of 1 to the 6th power plus 1. Now we know ln 1 to the 6 is still ln of 1. And ln of 1 we know is 0. And 0 plus 1 is 1, right? So the first condition is satisfied for the first limit. Now for the second limit, we're going to test the g now. And the g is going to be what? We're going to let g of x be equal to whatever we see in the exponent here. So in this case, the exponent is 1 divided by ln x to the 3rd power. Then, now let's check the limit to make sure that this agrees. The limit as x approaches 1 of the g is going to be substituting the value of 1 for x there. So it's going to be 1 over ln 1 to the 3rd power. Right? And we know this is 1 over ln of 1. And this is 1 over 0. Now 1 over 0, as you know, basically the limit doesn't exist, right? Because it's just infinity, right? And we know when you divide by 0, it's basically equal to infinity. In any case, the second condition is satisfied, right? So it diverges, the limit diverges here, goes on forever. There's actually no limit. But in any case, these two conditions are satisfied, so that shows we can definitely use this formula and find the shortcut value, right? So thus, let's use the formula. So the limit as x approaches 1 of the fx raised to the g of x is going to be, and let's substitute in the number. So it's going to be e, right, this great number that we know, which is about 2.71, raised to the limit as x approaches 1 of what? Let's substitute. F of x minus 1. F of x was what? Let's circle the f of x. So f of x was this, and g of x was this. We're going to need that, right? We're going to need that for substitutions. So let's substitute that. So f of x is going to be ln x to the 6th power plus 1 minus 1, not to forget, bracket closed, multiplied, this whole bracket should be multiplied by the g. The g is 1 over ln x to the 3rd power. So now what we have, using the fact that 1 minus 1 is 0, we know the ln x to the 6 multiplies the 1. Notice that the limit is still there, the limit notation, and this is going to be what? This is going to be ln x to the 6 divided by ln x to the 3rd. Alright, so this should give us what? Notice that using the properties of logarithms, 6 goes in the front of the ln there, and 3 goes in the front there, right? So it's going to be 6 ln x divided by 3 ln x. Now ln x cancels out, so that means no matter what the limit notation is, it will give us basically e, the limiting value will be e to the 6 over 3, which is e squared. So as you can see, we got the same answer using the quick shortcut method that the formula provides here. But again, don't rely on that, because your professor most likely will not let you use this. Some professors may, but not necessarily all of them. Unless they specifically address this formula in class, don't rely on that formula, because you might get the entire question wrong, or at most partially correct. So watch the video that will be suggested on this video on how to use the manual method, the most likely method that will be asked by your professor. Alright, so I hope this was helpful. Thanks for watching. See you in the next video.